Okay, what we'll do is just stop where you got to, and we'll go through these. Okay, so you might have got them all, or just a couple missing. You might not have got as far, but we'll go through it so you've got everything perfectly drawn. So, first of all, to start with, electrical circuits. Why do we need these symbols? Because it's a lot easier, and if you've got no artistic talent like me, it's easy to draw rather than having to draw like a light bulb or in real life, or a resistor in real life. Okay, so they're a lot quicker to draw as well. So we've got a few. These ones are most of the ones that you'll come across. You might come across a few more as you go through your electricity booklets. But wire is just a straight line. Cell is a short line and a long line next to it. It could be the opposite way around, the long line and the short line. That doesn't matter. Battery is two cells together, and they have to be the same way around. So short, long, or long, short, long, short. Lamp, circle with a cross in it. Switch is kind of like an open door if you were looking downwards onto it. A resistor is just a rectangle. A variable resistor is a rectangle with an arrow through it. Doesn't really matter which way around your arrow points, as long as it's sort of diagonally through it. Voltmeter is a circle with a V in it, and ammeter is a circle with an A in it. LED, light emitting diode, is a triangle pointing to a line with two arrows pointing away from it. The arrows represent something to do with light. So if it's light emitting, it will have arrows going away from it. It's sending out light. A motor is a circle with an M in it. A loudspeaker is kind of just like a 2D loudspeaker. You sort of cut it in half. So sort of a triangle with a little rectangle bit at the end. A photovoltaic cell is a cell, so a long line, short line, with two arrows pointing towards it. You can have these bits, but you don't need to have these bits. You just like connections into the circuit. So it could just be a long line, short line with two arrows pointing towards it. Fuse is a rectangle with a line straight through it. Diode is like the light emitting diode, but without the arrows. It's just a diode. And the reason that it's sort of like triangular shape is because it has to point in a certain direction for it to work, which you'll learn about in electricity 3. Capacitor is kind of like a cell, but they're the exact same length lines. Thermistor is a rectangle with sort of like a tick through it, but not a tick like this is flat with a tick. That's through there. An LDR, light dependent resistor, is a resistor, so a rectangle with two arrows pointing towards it. So you see, whenever there's a light involved in it, there's arrows, little arrows involved. Has everybody got all those written up? Does anyone need me to repeat any? Go back. Okay, brilliant. Right, okay, so we're going to start doing some circuits. So I wanted to, because last lesson, some of us were a little bit rusty with electricity, I think. Some of us didn't really remember much about it. So we'll sort of start from scratch. Hopefully you'll sort of pick up things as you go along and you'll sort of remember things. You might not remember things, it's okay, we're starting from scratch. So we're going to start with the two types of electrical circuit, series and parallel. Okay, so series is there's one big sort of loop of a circuit and there's no sort of branching off to go other places. So it's like you're all holding hands in one big circle. Okay, that's a series circuit. And a parallel one is there are more than one route. There's more than one route for current to flow. Okay, so we're first of all going to look at series circuits. Now, if you don't need them just yet, in the boxes, you've all got boxes at the side of your desks. There's a bunch of equipment. There's a bunch of equipment in there that you will need at some point. You might not need it all for each experiment, but everything's in there that you'll need for the next few lessons. There's also a set of photographs. Now, because I can't really go too close to you at the moment, what I've done is I've set them up previously and I've taken a photograph of what they should look like. So if anything's not working in your circuit, you can have a look at that, see if it looks like that. It might be that you just got faulty equipment. I haven't checked every single piece of equipment, and even if I had, sometimes they just break overnight for some reason. So we're going to start off with this series circuit. So what I'm going to do is I'm going to set it up on the board. And then I'm going to let you guys have a go. So the first one is should be nice and straightforward. It's a series circuit. So what you do when you set these up is you follow it step by step. So you can see right at the top of your circuit, you've got two cells next to each other forming a battery. Okay? And it's long line, short line, long line, short line. Okay? Luckily, our equipment has got the diagrams on there, so it's quite easy to follow. The first thing that you need to do is connect those together. So you put a wire in between the two. They have to be the same way around, because they normally won't work. They'll basically push against each other and cancel each other out. Then we've got, you can see where it says X, we've got a wire, and it connects down to a bulb. So we'll go from that side, from the short side of the cell, to one side of the bulb. Then we want to do the same from the other side of the bulb to another bulb. And then finally, we want to go from the other side of that bulb back to the cell. Hopefully, we'll get here. Mine are slightly lit up. They might not be really bright, but mine are slightly lit up. You won't be able to see very well on there, but should be able to see they're all set up. So that's how to set up a simple series circuit. They're all in one big loop. What you're going to do then is you're going to put a switch into points X, Y, and Z. And you can see there it says conditional blank when the switch is open. Okay? So and it says L1 and L2. So we'll name one of the lamps L1, the other one L2. The first one is X. So to put something in a series circuit, what you have to do is you have to break the circuit first of all. So X is next to the battery. So we pull out. We pull out the wire that was in the battery, and we plug it in. We make a little space for the switch. You have to get an extra wire. Plug it in there. Okay, so that's my switch on and off. Okay, so what I do in the table is I write down in position X, when the switch is open, that means off, both of my lamps are off. So I would say off and off for both of them. So can I go back to my notes? There you go. So circuit set up above. It's connected. Don't worry about a battery board. And a switch. Remember the circuit symbol for a switch is like open door. It's connected into X, Y, and Z. So in position X, my lamp, when the switch is open, which means off, L1 is off and L2 is off. Okay, then you need to take that switch out, join it back up together into a series circuit again. Then you want to pop it in between the lamps. So you have to disconnect one of these lamps, put the switch in, connect it back up with another wire. Does everyone think they're comfortable enough to have a go at this? Remember, the photos are there to help you if you're stuck. It will say page 12 on it. So have a go at that one. Give me 5 minutes. Yeah.